Alright, in this tutorial we will go over some programs and really see how we can go through the multi-step process that we have talked about in the last tutorial. That is defining the goal of our program, writing or defining the steps we need to go through, and then translating these steps into code or the programming language that we are using. All right. So let's start with the first program here, which is called variable swap. Here we can see the goal or the program that we need to write, which is write a program that swaps the values of two variables, x equals 4, y equals 12, and then print out the variables, right? So we start by declaring the variables x and y and assigning values to them. They can be any values you want, but we selected 4 for x and 12 for y. Next, print the current values of x and y. All right, we print out the values in order to see the current, we print out the variables to see the current values stored in them. The expected output will be 4 and 12. Now, let's start the swap process. We start by creating a temporary variable to hold the value of x. So we create a variable called holder, and we assign the value x to it, or replace the value of x inside it, right? So holder now is equal to 4. Now place y inside x, so x is now equal to y, so x now is 12, right? Next, place the value of holder inside y. Now y is equal to holder, which is 4. After that, print the current values of x and y. So we have two print statements here to see the old values and the new values. So let's execute the program to see if we have gotten the desired output. Here, execute it again. As we can see, the first print statement outputted 4 and 12 for x and y, and then it outputted 12 and 4 when we printed also x and y, which means the swap process was successful. Okay, now let's take another example, which is an even odd program. Let's take a look at the goal of this function. Write a function named even odd that takes a number as input or parameter and prints even if the number was even and odd otherwise. All right, so as always, whenever we want to define a function, we use the def keyword. It's a Python keyword as we talked about before. And then we specify the name of our function. In this case, it's called even odd. We can name it whatever we want, but we select a name that is representative of what the function achieves. Right? We talked about this before. Next, we open a pair of parentheses. And inside the parentheses, we pass the input or the parameter. All right, we don't pass actual values at this point. We just pass variables or parameters because at this point, we are just defining the logic of our function. We're not using it, we're just defining the function. Next, we use the colon in order to start defining the body of our function, right? Next, we go on a new line and we leave some white space. You see, all of these statements are indented below the def function, meaning that all of these statements belong to this function. All right. Now, the first comment or the first step is write an if statement to check if the number is even using the modulus operator. And this is important. Now, here we are being introduced to a new operator, just like the plus sign, the minus sign, the division, subtraction, and, or, etc., etc. We have another operator that basically calculates the modulus of or the mod of two numbers, right? So here we will use this operator, right? On the left side of the operator we have the number. On the right side we have 2, because to check if a number is even or odd, we will multiply by 2 and see the remainder. All right, so if the number uh, mod 2 was equal to 0, meaning that the remainder was 0, meaning that there was no remainder, it means basically that the number is even. So if this condition was true, if the number mod 2 was equal to 0, then we can go to the this statement that belong to the if statement and print the number entered is even, right? Else, meaning that the function was false, we go to the body of the else and see the print statement, which is print the number entered is odd. Okay, and again, please pay attention to the indentation here and the colons for both the definition of the function and the if statement, right? At each time we use the colon, we go to a new line, we leave some indentation or white space, and then we write our statement. Same thing for if here. We use the colon, go to a new line, we leave some space, and then we write our statement. Same thing for else. All right. Now, let's test out this function that we have just written. So test the function on odd and even numbers. So we create three variables, number 1, 2, and 3, and we assign the values 3, 12, and this number here. All right. So at each time, we start by calling the function that we have just defined. So at this step here, we have defined the function, right? In the next steps here, we actually call or use the defined function in order to produce something meaningful, right? So the first time we call the function even odd. All right, now we pass the input or actual value that we want to process. In this case, we pass number 1 or 3. So the expected output is the printed out sentence, the number entered is odd because the 3 is odd. The same thing we will call the function even odd on number 2, which is 12, and we will call it again for number 3. Right, now let's execute this program and see the output. You see, the first one is the number is odd for 3, for 12 is even, and for the third number it's even. And we can see it's even because the last digit is 8, which means that this number is divisible by 2. All right, now one more thing is whenever you want to use an operator or to understand what a particular operator is for, you can always refer to the documentation of the programming language you use, whether it's official or not. Just navigate to an documentation that basically lists out all the functions and operators you can use in a particular programming language. So here, uh, actually, there is a website called W3 Schools that basically lists all the operators that can be used within Python, right? We can go to the official documentation on python.org, but this documentation here is simply easier to navigate. All right, it's offered again by a website called W3 Schools, which is actually a great website that offers different tutorials in different programming languages. All right, so let's see Python arithmetic operators. We have the plus, minus, multiplication, division, and you can see, as you can see, we have the modulus here, right? The same thing for go for the assignment operators, different ones. Comparison operators that we talked about, logical operators, identity operators, membership operators, and so on and so forth. So whenever you need an operator, just navigate the documentation, pull it out, and place it in your project. Okay. Now let's go to uh, another program called the average list items, which is basically a program that will calculate the average for a list of items, right? So let's take a look at the goal. Write a program that counts and then prints the words in the list below. All right? Uh, uh, the words in the list below. Okay. It seems that this comment that I've written is incorrect in this case. The program we want to create is a program that gets the average as we discussed. So for now, let's delete this comment. All right, so to do that, we start by defining a simple list called myList. All right, and we place the numbers 30, 12, 43, 22, and 19 inside it. Next, we declare two variables to hold the count and sum and set their values to 0 initially. So we create a variable called list count equal to 0 and list sum equal to 0. Can we name these variables anything else? Absolutely. They are just names that are representative of the value placed inside them. Next, loop through the list to calculate the sum and count. So we want to loop through these numbers and add each number to the total, and at the same time increase the count by 1 in order to get the total or the sum and the count by the end of the for loop. So we start by using the for keyword. Next, we use a variable to hold each item in the list. We called it item. Can we name it anything else? Absolutely. All right. Remember, we used the variable rice once in a for loop, which is totally fine. Anything can be used. Next, we use the end keyword. All right. Next, we use the list that we want to loop through, which is called my list. Right. And next, we use the colon to start defining the body of our for loop, or basically to define the statements that we want to be executed at each iteration, right? Which consists of these two statements. So these two statements will be executed as many times as there are iterations in this loop right here. All right, so at each iteration, increase the list count variable by 1. So we say list count equals to list count plus 1. And keep in mind that the left side of the equal sign or the assignment operator will be evaluated by Python before the left side. All right, and here we have the operator plus, which has precedence over the assignment, by the way. So here we take the list count, the previous value of list count, add 1, right, and then place the new value inside the list count. So we are basically updating the list count variable. Next, we do the same thing for the sum. We say list sum equal list sum plus item, where item at each iteration will store one of these variables, 30, 12, 43, 22, etc. So at each iteration, it will add a new number to the total or the sum. Now, once Python hit the end of the list and there are no other elements in the list, the for loop terminates and the program presumes execution after the for loop. All right, so after the for loop is over, we create another variable called list average, and we set it equal to the list sum, right, divided by the list count. List sum divided by the list count in order to get what? The average. Again, the right side is evaluated before the left side when we use the equal sign. All right. Finally, we simply print the list average to see the value on the screen. So let's see if we get the expected output. We run the program, and as we can see, the average is 25.2, which is the total of these numbers, right, divided by 5. All right. Okay, let's take another example. Here, we simply want to print out the multiplication table, right? So to do that, we start by creating two lists to multiply them by each other, right? So we have list 1, which consists of the numbers from 1 all the way to 10, and list 2, which contains the same numbers, right? Next, loop through list 1 and multiply each number by all the numbers in list 2, all right? So we say for x in list 1. All right, so x initially will be 1, then 2, then 3, all the way to 10. Now, uh, now we get inside the body of the outer loop, right, or the first loop. So we have an outer loop, we have an inner loop. So the outer loop, or the body of the outer loop is all of these statements. Why? Because they are indented further. Okay, so first, print a message telling which number we are multiplying by. So we say print multiples of x. So we start by the multiples of 1. Next, we say for y in list 2. So y initially will be equal to 1. All right. Next, do a multiplication and store the result in a variable. So result is equal to x times y. Then we print the result of the multiplication, right? And this loop will keep iterating through all the elements in list 2 while keeping x fixed. So x will remain 1 initially. And then y will keep changing from 1 to 2 to 3 to 4 to 5. And at each iteration, we multiply an element from list 2 by the first element of list 1. So at the first iteration will be 1 by 1, 2 by 1, 3 by 1, 4 by 1, 5 by 1, 6 by 1, 7 by 1, 8 by 1, 9 and 10 by 1, right? When done, all right, we will print a new line or go to a new line to print the multiples of the second number. Now we will go back to the outer loop here, right? And now x instead of 1 will be 2. And then we will get into the inner loop where we loop through all these numbers and multiply each one of them by 2. So it will be 1 by 2, 2 by 2, 3 by 2, 4 by 2, 5 by 2, all the way to 10. Next, x will be updated to 3. And then we will go through all these. So 1 by 3, 2 by 3, 3 by 3, 4 by 3, 5 by 3, all the way to 10. All right. Now, at the end, this outer loop will reach the end of the list, right, which is 10. 10 is the last number. After that, there are no other items. So this for loop finishes execution and the program terminates. All right. So let's see if we've gotten the output expected. Here we go. See, at first iteration, we have the multiples of 1. We have 1, 2, 3, 4, 5, 6, all the way to 10. Then multiples of 2, 2, 4, 6, 8, 10, 12, 14, etc. Then multiples of 3, right? Multiples of 4, multiples of 5, 6, multiples of 7, multiples of 8, multiples of 9, and finally the multiples of 10. All right? And this is one of the, again, examples where using code tracing that we talked about, it becomes very, very helpful to understand the order of execution or the way these statements actually work, right? So here we nested two loops inside each other, right? So when you see it for the first time, you might get confused. So the solution to this is to use code tracing and see how the different variables are updated in real time, which eventually will make the program more understandable. All right. Okay, let's take another example here called min-max functions. All right, so what is the objective or the goal of this program here? Write two functions, min and max, that return the minimum and the maximum value in a list passed as input to the function. So here we will create two functions, function min and function max. Min will find the minimum, max will find the maximum. All right, so let's start with the min function. Define a function called min and place a list as input or parameter. So this function as input will take a whole list, all right? Search through the list for the minimum and then return that minimum number for us. It's as simple as that. All right. So we start by the def keyword, then we use the min, the min for the function name, right? We open parentheses since it's a function, right? And then we pass our parameter or variable. Okay, now we leave some white space and we go to the next statement. Create a variable to hold the first number in the list as the minimum. So current min is equal to my list of 0. And remember, to access certain elements from a list, we use indices or indexes. To access certain elements from a dictionary, we use keys. And we've talked about that before, right? So current min is equal to my list of 0, meaning get me the first element in the list and set it as the minimum initially. All right. Now loop through the list. All right, loop. We have a loop, so we use the for loop. For num in keyword and my list. Do you know what the list is? Not yet. All right. We will know it once we actually call the function. Next, we use the colon and we go to a new line to define the body of this for loop. Here we check if the current number in the list is less than the current minimum. Okay, so we say if num less than the current min. So if the current element we are handling in our list is less than the current minimum, all right, then we update the current minimum to this item. So If it's less, update the current minimum and set it equal to the current list item. Otherwise, we will do nothing and we leave the current minimum as is. All right, so if this was true, then this will be executed. Otherwise, this will not be executed because the condition here was false. Okay, now the for loop will continue until it gets to the end of the list we are searching the minimum for, right? After the loop is over, we will return the minimum. So we say after the loop is done, return or produce the current minimum as output. So we say return current min, right? It's a very simple program, and it's supposed to make sense. All right, now let's test out this simple function here and create two lists of random student grades. All right, we have Alex grades and we have Bob grades with different grades for each one of them or for each variable. Now call the function twice and pass each student grades as the input argument and make sure to create variables to hold the output. Right, so we want to call the function twice, which will return the minimum, and that will be stored inside these variables, Alex min grade and Bob min grade. And remember, when we call the function, what will happen is that Python will go to the function definition, return a value, and then replace the whole function code with that returned value. So the function returns 18, then this whole function code will be returned by 18. All right. Now, at the end here, we will print the minimum grade of Alex and Bob by printing out the variables Alex min grade and Bob min grade. All right, so let's execute our program and see. So here for Alex, the minimum was found to be 55, which is actually the minimum, right? Looking at these numbers. For Bob, the minimum was 54, which is actually the minimum. So our function worked as intended, right? Now I will leave it to you to actually define another function called max or maximum to find the maximum, right? Which requires a very simple tweak in one of the statements here to do the trick for us. All right? Okay, great. Very great. Now, we'll go to a new function called search item, which basically takes a list or as input or parameters takes a list we want to search through and the item we want to search for. All right, so we have two inputs. So let's read the goal of the function here. Write a function called search item that takes a list and an item as inputs or parameters. All right, and return true if the item was found in the list and false otherwise. Right. So as always, we start by using the div keyword. Then we specify the name of our function, in this case, search item. We can name it whatever we want, as we discussed before. Then we open pair of parentheses, right? And we specify our parameters. We call them mylist and search item. All right, next, create a variable called result and set it equal to false initially. So result means that the item is not found. Initially, it will be false. However, if the item was searched for and it was found, then result will be updated to true. All right, so loop through the list. So we say for item in my list that we will pass. Next, check if the current item in the list is equal to the search item, right? So if item, which is the current item in the current iteration, is equal to the searched item we are searching for, right? Then if it was found, update the result variable to true. Then we say result is equal to true. Again, pay attention to the indentation or white space we are leaving after the fors and the defs and the ifs. It's important. After the loop is done, return produce the result as the output. So finally, we simply return the result, which can be either true or false, depending on whether the element was found or not. All right, let's take an example. Let's test out our function here. By first defining a list called the list of two items, two string items, in fact, dog and cat. Now we will call the function and store the result inside the variable called status, right? So we call the function search item. Then we pass the first or we pass the list bits as the first argument or input, and then we passed the string cat as the item to be searched for. All right. So Python now will go to the search item definition, set bits as my list, and set cat as my searched item. Now, what do you expect the output of this function to be? Will it be true or will it be false? Now, let's print out the status, right, to see the result that we will get. Let's execute the function, right? It's true because cat is in fact in the list. What if we added this simple letter here and then we executed the function? As you can see now the value is false, right? And we can do that however much we want. Again, it's a very simple function with two inputs, right? Some functions can take 3 or 4 or 5 inputs depending on your need. In our case here, we needed 2 inputs, a list and a searched item. That's why we set 2 inputs, right? So you don't have to stick to any of the different characteristics of the functions we are using here. It's up to you. It's up to the logic you have in mind for your program or function. All right. Okay. Now let's take a look at some built-in functions. And remember, we mentioned before that there are two types of functions, right? We have built-in functions and user-defined functions. The user-defined functions are the ones that we, the programmers, define and then use, right? Built-in functions are functions that have been defined by some other programmers in the past, and all we have to do is to use them or tap into them. All right. So here we have defined a variety of functions, or sorry, not defined. We have actually used some of the built-in functions to achieve different tasks. So here we use call use a built-in function that takes a number input and returns the absolute value of the number. Example, if the input was negative 3.59, then the output should be 3.5, which is basically the absolute value, right? For this, we create a variable called x and we set it equal to the built-in function called ABS or apps in Python, right? So we just call the function and we pass the value we want to find the absolute value for, right? And then we print out the result of x. Okay, so all we had to do here is to call our function and pass an actual input for it. We didn't have to define the function. In this case, Python automatically will go to the definition that is stored somewhere you can see and replace this whole function call with the actual absolute value, which will be 7.2. All right. Let's use a built-in function that takes a number input and return the number routed to the nearest integer. Example, if the input was 12.69, the output should be 13. All right. All right, here we created a variable called y and we called the function round, right? And round is a function that takes two inputs. All right, the first input is the number you want to round, and the second input is the number of decimal places you wish to have in your number. And then we print out y. This is very good example because you might be asking yourself the question, how did we know that this function takes two parameters? I mean, you can't see the definition. I can't see the definition, right? In this case, we always go to the official documentations of these languages, in this case Python, in order to see the different functions along with descriptions of how to use them and how many parameters we need to pass to them and what type of value is returned by them and so on and so forth, right? So here we go to the documentation of Python's built-in functions, right? And again, there is official documentation on python.org, but this one is easier to navigate and it serves a purpose at this point. All right. So here, as you can see, we have all the functions along with some descriptions of them. So absolute, it returns the absolute value of a number. Let's click on it and see some more details about it. So here, the absolute function returns the absolute value of a number with an example, right? Definition, the absolute returns the absolute value of the specified number. Here we have the syntax. Here we have the parameter values it takes, which is n, which should be a number, right? Here we have some more examples. We can go back and go through the list of built-in functions to either find a particular function or to understand how a particular function works. All right. So in this case, we use the function round, right? So let's see if we can find round here. Here we go, round. Rounds a number. So we click on it. As you can see, the round function returns a floating point number that is a rounded version of the specified number with the specified number of decimals, right? We have the syntax, we have the parameter values it takes. Okay, it takes a number and the digits, which is the number of decimal places. And as always, we have some more examples of it. Now, again, in this case, we use the round function. We passed this value and we wanted the value to be rounded to 2 decimal places. All right, we will execute the function later on to see how it works. Let's now go to the third built-in function and see how it's used. Use a built-in function that takes a list and returns the length of a list, which is the number of items inside it. So example, if the input was 1, 5, 12, 19, the output should be 4, right? So in this case, we can use a built-in function in Python called len, and we can get more information about this function again using the documentation here. So let's see if it's here. Here we go, len function. We open it up. As you can see, it returns the number of items in the list along with all the details pertaining to that function. All right, please make sure you understand the fact that there are documentations to help you use the different functions because you can't remember all these different functions along with their different parameters. It's very hard, right? Now call a built-in function that takes two numbers, x and y, as input and returns x raised to the power y. So x raised to y. So if the input was 2, 5, the output expected is 32. In that case, we use a function called power, which takes the base and the exponent, and then we print out the result. For the function, built-in function that takes a list as input and returns the same list but reversed, right? For that, we use a built-in function called reversed, right? We create a list, we use the function, we store the value, and then we loop through the characters of the reversed string and print out the letters, right? Next, call use a built-in function that takes number x as input and returns a sequence of numbers that start from 0, increments by 1, stops at the number x minus 1. All right, so we have a function called range, which basically returns or produce as output, right, a list or a sequence of numbers starting from 0 all the way to the number specified minus 1. So if set range of 3, it will return a list of the items 0, 1, 2, 3. Set range of 7, it will return a list of 0, 1, 2, 3, 4, 5, and 6. This is a very helpful function, and you're going to find it useful later on. It's called the range function. All right. So we return the list and then we loop through the list to print out the numbers. It's very simple. Finally, we have a built-in function that takes a list as input and returns output the same list but sorted. Simply a function that sorts a list, right? So here we have W and then we call a function called sorted, and as input we pass the whole list here. What will be returned? The sorted list. All right. So let's run this. Uh, let's run these function calls and see the outputs that we will get. First, for the absolute function, you see the output 7.2 expected, and correct. Second, 2.6485 rounded to 2 decimal places is 2.65. That's correct. Third, we have print len of z. Z has 4 elements, so the output expected is 4, which is 4 here. Next, power of 2 to 8, which is 256, which is expected. Next, we take this list and we apply the reversed functions, and then we loop through the reversed list. So the output expected will be DCBA, right? As we can see, DCBA. All right. And then we have the range function, which loops through the list from 0 to 8, right? Here we go. For number in R, print number. So we'll have 0, 1, 2, 3, 4, 5, 6, 7, 8. All right. Finally, we have this list, right? And we apply the sorted function to sort it out. So the elements sorted are -9, -3, 8, 15, 18, and 40, which seems correct, right? So as you can see here, we have managed to tap into so many functions that are already built in, that are already written, and all we have to do again is just to use them, right? This is very, very powerful and can help us build very big projects from these functions or components. Okay, finally, we have a very simple program with the input function, which can be helpful at times, right? The input function simply allows the user to input some values to the program, right? So here, as you can see, write a function that prompts the user for his or her full name, and then prints a welcome message using their entered name, right? So we define the function welcome. Inside welcome, we create a variable called num, and we set it equal to the function called input, right? Then we print welcome name depending on the input the user entered. Down below here, we call our function welcome. Let's execute. Here we go. Let's run it. Welcome, right? Run it again and enter some name. Say Ben. Welcome Ben. Right? Let's change the name something else. Anna, my name. Sorry, we need to rerun the program. Right? Enter. Welcome. See, this is the input part. The cursor of Python waits for you to enter a value, and then it prints out the welcome message for you. All right, so these were the programs that we had for today. I hope you found this tutorial informative, and I hope you learned the skill of navigating the documentation to get the functions that you need to integrate into your project to make it actually work. All right. All right, so feel free to leave us a comment. Make sure you subscribe to the channel, and I will see you in the next tutorial. Thank you.